Okay. First of all, thanks everybody for joining this session at the MySQL conference in Brazil. It's a big pleasure for me to be here with all of you. Now, is this working? Yes. Now, quick introduction about myself. My name is René Cannaò. I am the founder and CEO of ProxySQL. I have been involved into MySQL for very long time, so I've been working as MySQL support back in the day and have been supporting a lot of big companies since then. I am very passionate about high performance, so this was my main area, and this is why ProxySQL was born. Just quick, raise hands, who knows ProxySQL as a product? Okay, very nice, thanks. Now, quick agenda. So we are going to speak briefly about MySQL, what is MySQL after 30 years, what are the big achievements, and then we are going to speak about why the traditional approach in scaling MySQL has problems, so where they hit a wall basically. Then we're going to introduce what ProxySQL is, and we will speak about his main features. ProxySQL has really a lot of features, so we're not going to cover them all. We're trying to compress as fast as possible through the main features. And then the last section will be takeaway and Q&A. Now, MySQL started as a very small project back in the day. Initially, it was a database developed for the web, very fast. But then, as times pass and more users started adopting it, it becomes now an enterprise product that is used by very large corporations. And this becomes especially true after Sun acquisition and Oracle acquisition, and now ProxySQL is now MySQL. Sorry, has a lot of focus on availability, security, and so on. Now, what is the problems that MySQL has when it comes to scale? Well, nowadays, database infrastructure are becoming larger and larger. So as they grow, there are more different challenging in how to achieve high performance, stability, and especially when you have a lot of user interface that depend from the database application, depends from the database to be responsive, and so on. Now, what are the challenges in MySQL and performance in general? Well, there are several ones. One of them is, for example, the fact that the way MySQL handles connection. So in MySQL, every client connection is a thread, so you have one thread per connection model. This means that every connection, even if it is idle, is consuming resources, whatever it is, CPU, memory, and so on. So what happens is that this creates some scalability issue because you cannot have hundreds of thousands of connections because this will result in hundreds of thousands of threads. So even threads that are completely idle will slow down the database and affect the threads that are actually serving traffic. Then we have also operational problem. So the operational problem is, for example, if you have just one machine, everything works fine, right? Well, of course, you have some limitation, like you need to provide availability and so on. But if everything is one machine, everything is simple. But as soon as you start scaling out and you add more machine, whatever it is for HA or for scaling reads, then you start having a series of challenges on how to handle multiple MySQL server at the same time. And those challenges are normally on the operational side. And then we have also application issues, like how do you combine the application and database. Because, for example, if you have a topology that is changing, that is evolving, that is scaling out, the application often need to know where is the writer, where is the reader, where the data reside, what happened if a failover happened. So you end up in a situation in which you have tight integration between the database server and the application. And of course, all this creates dependency and increase the complexity. So now that we have defined what are the problem, let's define what are the classic solution and why those solutions do not really work. So first of all, MySQL itself does not have any native tools to actually provide some sort of availability. So, if a MySQL server dies, you need to fail over to another machine. And you normally have tooling for this, so that's a good thing. But still, even if you use technology clustering solution like group replication or DB cluster, you still need the application to know if one server went down and where is the new server that has to replace it. So even if MySQL has some tooling around it, you still have some difficulties in handling how this is managed by the application. And what about proxies? Well, historically there have been several proxies that are level 3 and level 4 proxies. And the challenges with those proxies is that they do not understand anything about the traffic itself. So they are like just TCP proxy. So they take a packet from one end, send it to the other one, and they have absolutely no idea what is passing through it. So they have a series of limitations. And as I was mentioning before, even with those solutions, you still have complexity on how to integrate the application with the database. So how to solve all this? Well, to solve all those problems and way more, this is where ProxySQL was born almost 12 years ago. And is basically a very high performance proxy for MySQL, initially for MySQL. Now we are supporting more database as well. And is SQL aware. This means that every time a query is passing through ProxySQL is actually able to understand what the queries is. And so is able also to understand the boundaries of the query, the boundaries of the transaction, and so on. So it knows what is running. And it basically manages all the life cycle of the query from the connection until the results that is returned to the clients. So let's get into a bit more details. OK. So this is a very basic diagram on how ProxySQL works. Extremely simple. So you have an application connecting to ProxySQL instead of connecting directly to the database. ProxySQL will know everything about the database infrastructure, so it will determine where queries need to go, and then they will return the results to the client. So all the logic about what happens when a server dies, or if a query is a write or is a read, or if a query is from a specific user that need to go on a specific cluster, all this logic, it will be embedded into ProxySQL and not anymore in the application. OK. So as I was mentioning, basically what ProxySQL does is create a boundaries between the application and the database. So it is able to decouple the two, because now is the one in the middle and is the one that implements all the logic related to routing. So this means that developers do not need to care anymore about where the database is, because the logic is moved away from there. And this also means that DBAs and the operational team, they can perform any sort of operation on the database without affecting the application. So historically, it was required maintenance, and the two teams, like the development team and the operational team, need to collaborate very closely, because every time there was the need of performing an operation database, the developers need to be aware and making sure that everything works properly. Now, with ProxySQL, this problem is solved because it's completely transparent between the two teams. Now, let's start diving into some of the most important features. The first one is connection multiplexing. So as I was mentioning before, because of MySQL has a one thread per connection model, this means that if you have a lot of connection, you will have performance degradation in MySQL Server, because MySQL will spend most of its time managing the connection instead of serving traffic. So what ProxySQL does instead is you can create as many connections as you want to ProxySQL, and ProxySQL will be able to have only few connection to the database server, and this will drastically reduce the amount of resource utilization of the database server, and therefore increasing performance. Let's just have a quick show on how it looked before ProxySQL. So if you have thousands of application server, all the application server will create their own set of connection to the MySQL server, and MySQL server will be overloaded. The new diagram instead will be something like this. So you can have thousands or hundreds of thousands of connections from the application to the database, and ProxySQL will only have a few connections to, hundreds of thousands of connections from the application to ProxySQL, and ProxySQL will have only a handful number of connections to the database server. How many connections, it really depends from your specific workload. If you have a transaction, how complex are the transactions, and so on. But ProxySQL has logic to try to minimize the number of connections required. And you might end up in a situation like this. So if basically you use ProxySQL, you drastically reduce the number of connections to the database server. You also reduce drastically the amount of CPU utilization on the database server. And this means that the database server can also do more work. So you can have like the P95, P99 reduced drastically. We have a lot of customers in which the number of connections to the database actually drops by a factor of 100 when they deploy ProxySQL. So imagine passing from 10,000 connections to just 100 connections. This is actually real scenarios. Hello? Okay. Good. I don't know why it's not switching. Okay. Query routing. Query routing is probably one of the other main features of ProxySQL. So ProxySQL, as I was mentioning before, is SQL aware. This means that every time you see a query, it is able to analyze the query. And by the fact that it is able to analyze the query, you can create rules and specify what to do with that specific queries. It could be anything. It could be file filtering and so on. And one of the most common one is routing. So based on the query itself, ProxySQL, you can create rules in ProxySQL to decide what to do with that specific query. A classic example is a read-write split, in which you have a primary that is taking writes, and you have a replica that is taking reads. But this is a very basic example because you can have way more. Like you can have sharding based on schema, based on users, based on specific table name, and so on. And yeah, so here, continuing on the example of read-write split, very basic example, you can create a rules that says, okay, everything that is a select for update, send it to the primary. Everything else that is a select, send to the replica. And of course, everything else like insert, updates, and so on, so the DML, they all go to the primary. A quick disclaimer, this is a very basic example just to fit in a slide. Of course, do not do this in production. Do not create very generic rules like all the read go to the replica, because actually it's better, because you might have cases in which you want some specific read to go to the primary if you are not, if your application is replication log sensitive. So this is how it will look. So basically, you will have the application that connects to ProxySQL, and ProxySQL has its own engine inside. So based on criteria that you will define, it will send the query to either the primary or to one of the replicas. Okay. Another features of ProxySQL, very important, is that provide high availability. So the way it provides high availability is that every time you have a situation in which one of the server goes down, normally what happens is that you have downtime. It's quite common. So ProxySQL tried to solve this because it's able to detect every time a server is going down and is able to determine which one is the new writer, or if what went down is a reader, it excluded from the pool, and is able to route the traffic to the correct server. So how the failover actually happened. So the failover happened in multiple stages. So the first stage is in which the server actually fails. Then there is a phase in which the new writer is being elected. This, of course, depends from the clustering solution you're using. So if you're using standard MySQL replication, you probably have some tooling like Orchestrator. Instead, if you're using group replication or Galera, you have the cluster itself that will elect a new writer. What ProxySQL will do is it will detect which one is the writer, and it will transparently, without any application, without the application ever noticing, it will automatically redirect the traffic to the healthy server, the server that now has become the primary node. And the part that is completely transparent to the application is extremely important, because the application doesn't even notice that the server went down. From an application point of view, what the application can see is that there have been latency of like 1 to 2 seconds. So for 1 to 2 seconds, queries were not being executed, but the application will not get errors. The application will just see a delay in query being executed, because ProxySQL is able to hold the request until a server becomes available. So this is a very basic diagram of how it looks like. So in this case, we have an healthy writer and 2 healthy readers. What happens if the current writer goes down? The cluster will elect the new writer. ProxySQL will detect this, and it will start using the new writer to send writes, and the remaining replica will be used only for reads. Okay. Another common problem when you have automatic failover is that you have a situation in which you have a split brain scenarios, in which it might happen that you end up in a situation in which you have 2 writers at the same time. ProxySQL now is able to prevent this situation, and if it detects that there is more than X number of writers, the classic example is 1. So if it detects that there is more than 1 writer, it will automatically stop sending any sort of write until it goes back to only 1 writer. So it prevents split brain scenarios. Split brain scenario can happen if you have network partitioning and so on. Okay, now another common use of ProxySQL is to send read to a replica, and of course only send read to replica that are reasonably in sync with the writer. So you can configure ProxySQL to check replication log on each of the server. And of course, this is asynchronous replication, group replication, Galera, doesn't matter what it is. Based on the clustering solution, you define the type of clustering solution ProxySQL will use the right monitoring to determine the replication log. And so you can configure it to send only reads traffic to servers that are in sync or within a certain threshold. Classically, this diagram describes it. So you have a writer, a set of replicas, and ProxySQL is constantly monitoring the replication log. If detect that one of the replica is lagging way too much, so beyond a certain threshold, it will stop sending data requests to that specific replica until, of course, replication is back in sync. Query write. Okay, also this one was one of the main features when ProxySQL was developed. So the ability of identifying queries that are not performing very well, so bad performance, and ProxySQL can on the fly rewrite the query without the need of any application code changes. So because the query is passing through ProxySQL, you identify the query and you say, okay, you can create a rule that say every time that you're seeing this specific query, rewrite in a certain way. The way it uses just regular expression. So here is an example. For example, you want to remove, you don't want to use a select star, or you want to pass an index hint. So you can have something like this. You have an application, a legacy application that sends a select star from a table name where a specific email is specified. And you say, OK, I want to remove select star. Instead of select star, I want to list all the columns that I am interested in returning to the client. And I also want to force an index or hint an index. So basically, the application will send the original query to ProxySQL. ProxySQL will rewrite the query and send it to the backend. So here is a more specific example. You have the original query and the rewritten query. ProxySQL can do this very easily. Now, another interesting features, a common problem, query caching. So if you have an application that is sending over and over again the same queries, ProxySQL has a built-in query cache. So if it sees the same queries being executed multiple times by multiple clients, it's able to cache this query, and you define a TTL for it. The way it works is that this is a very basic diagram. So the client sends the query to ProxySQL. ProxySQL will check if this query is cached. If it is cached, it will return the results directly from its own query cache. If it's not cached, it will send the request to the backend. And then when the backend returns the results, it will store it in the query cache and return the results to the client. And this also means that if you have thousands of client applications that are all sending the same queries at the same time or within a certain time threshold, ProxySQL is able to serve everything from the cache, so it's extremely efficient. Of course, this principle works only if you have the exact same queries executed multiple times by the client. If instead you need something a bit more advanced, I recommend to use ReadySet, that is basically able to aggregate result set from specific tables and caching those results so the client can queries using ReadySet. Now, what are other interesting features of ProxySQL? Well, as I was mentioning before, ProxySQL sits between the application and the database server. This means that it's able to monitor all the traffic and is able to perform any sort of data collection about the queries. So not just what queries are being executed, but where they are being executed, from which user, which client, what is the response time of every query, and so on. And because it's able to see all the traffic, it's able to collect the real-time statistic about all those metrics. And it's able to export those metrics. There are multiple ways of exporting those metrics. You can have either through the admin and statistic interface, so using SQL, or you can export them using the Prometheus exporter. So there are multiple criteria. So this means that it's also very easy to integrate those metrics into third-party monitoring tools like Grafana, Prometheus, and so on. Why this is important? Because ProxySQL itself is able to improve the performance of your database. But once you're able to collect a lot of statistics about the queries and identify query pattern, identify application pattern, how the queries are being executed, once you have all those information, you have a lot of details on how to improve the processing of data even further. So you can use all those information to reconfigure ProxySQL and make the data flow and the query life cycle even more efficient. So you can have a DBA that is able to analyze all those metrics and reconfigure ProxySQL even better. Now, other features in ProxySQL are like query throttling, firewall, and security. Let's go into some of those, for example, like query throttling as the first one. ProxySQL has different ways of protecting the database, and one of them is, as I was mentioning before, is using connection multiplexing, but it's not the only one. You have other one like query throttling. When you identify that certain query pattern they have been stressing the database way too much, and this can happen, for example, if you have an application bug and the application is sending similar queries way too fast, you can artificially delay those queries. And again, you create just a query rules, says, okay, every time you're seeing a specific query pattern, delay it by X number of milliseconds. This is one of the approach. And another approach is instead limiting the number of connections that a specific query pattern can execute on. So for example, in this example, I made it very simple. Like in the database layer, there is one writer and one reader. The reader will take all the reads, but you can specify that if some specific queries or some specific select statement against a specific tables, for instance, they can only use X number of connection to the database server. This means that if you have some queries that are stressing the database way too much, you can just limit them in this way, just creating a host group that has a low number of connection, and those queries will basically have contention, and they will compete for who can run on those limited number of connection. So you artificially constrain how much load they can create on the database server. Firewall. We have multiple ways of doing firewall. In this diagram, I described just a very simple one. So you can create query rules that says, okay, every time you identify a specific query pattern, this query can be blocked. And ProxySQL can block it in a different way. It can either return an error to the client or just return an OK to the client without actually executing the query. Let's assume that you want to block a delete statement, a specific delete statement. You can return an error to the client says delete against this table is not allowed, or you can tell the client an OK message, so the client will believe that the delete was executed while in reality nothing was executed in the backend. This is the very basic form of firewall. We have way more complex firewalls that use a whitelist approach, so you define all the queries that can be executed, and everything else is automatically rejected. Time. So, what are the use case of ProxySQL after all this description? So, ProxySQL can be used in every sort of setup in which you need read-write split or complex routing. One thing to remember is that ProxySQL can scale and handle a big number of connections, not just hundreds of thousands of connections, but also is able to handle a very large number of backend servers. We have customers in which behind every ProxySQL instance, they have thousands of MySQL servers. So it's able to scale very well. And is able to support any sort of clustering solution. So as I was saying, classic asynchronous replication, InnoDB cluster, Galera, but also Aurora, GCP Cloud, and so on. And it works very well, no matter if you are running ProxySQL just in one availability zone or you are running across multiple regions. Its main workload is, of course, OLTP, so it works very well for any sort of for fine text, software as a service, and so on. And yeah, it's being used by very large infrastructure, so it scales very well. So at the end, why choose ProxySQL? It's scalable, is able to scale very well, very lightweight, and even if it is lightweight and provide a lot of features, it can handle really a large number of connection and setup. Very good performance. So we often run benchmark against a similar product or against MySQL, and often just deploying ProxySQL is drastically able to improve performance instead of running queries directly against MySQL. It improves the reliability of the server because it is able to automatically handle identify when a server is malfunction, so it's able to handle failover. And is able to export real-time statistic, so it's very good for observability. It's easy to adopt. Normally, you don't need to make any application change. If it's very rare the case in which you need to make any sort of application change. Normally, you don't need to make any change in the application. All the configuration is in ProxySQL, so you move away the complexity from the application. The application, normally, all you have to do is just pointing the traffic to a ProxySQL instance. And finally, is able to provide security because we have several technology that not only block traffic, but they also mask data from the client whenever this is needed. So, key takeaway, ProxySQL is able to decouple the application from the database server, so it creates a layer in between. So this means that the responsibility of the developers and the responsibility of the DBA are very well defined, and ProxySQL is the one in the middle. This allows to centralize, control all the complexity of the database infrastructure. And finally, is able to provide a lot of features that will generally improve the performance of the database infrastructure. Question?
I do have a question. We heard in the lunch today, does ProxySQL support LDAP or multi-factor authentication at the moment, or if not?
We have a plugin for LDAP, but only for enterprise customers. We might have different plans for it, but currently, yes, we support LDAP through an enterprise plugin.
Okay, and do you have any other features that are available only on enterprise version?
No, not that. We have the web UI that is only available for enterprise customers. That basically the web UI is allowed to easily configure ProxySQL through a wizard, so it will make the configuration a lot easier, user-friendly.
Okay. Perguntas?
In Aurora, you can scale based on usage, right? If you
In Aurora? Sorry, in Aurora?
In Aurora, in AWS Aurora, you can scale based on usage, based on CPU consumption, for example, right?
Yes.
And when the workload goes down, the instance starts shutting down.
Yes.
Proxy detects this fast enough.
So ProxySQL is able to, the logic that I was mentioning before, that ProxySQL is able to detect when a server goes away, of course it applies also to Aurora. So if a server disappears, ProxySQL doesn't care if it is Aurora or anything else. It will stop using that server. Now, in case of Aurora, what becomes interesting is that ProxySQL is also able to detect when a new node is added. So it has auto-discovery. So when you're using Aurora and Aurora automatically scale out, adding new replicas, ProxySQL is able to detect it. And when a replica goes away, ProxySQL is able to detect this as well.
So it's better to use the ProxySQL to attach the instances to the ProxySQL instead of use the reader endpoint of the Aurora cluster?
Yes. And ProxySQL is automatically able to detect which one is the writer, which one is the replica. Actually, with Aurora, we have a lot more features because Aurora, what allows is to define replication lag in millisecond. And in case ProxySQL detected there is Aurora, ProxySQL, you can define replication lag in millisecond. And also for Aurora, we have a lot of other features, like one of the things they are introducing right now is the blue-green deployment. We are working closely with AWS to implement features in ProxySQL that will allow the deployment of ProxySQL on top of blue-green deployment.
Mais perguntas?
Rene, can you tell us a bit how ProxySQL compares to the MySQL router?
Yes. Actually, I had a slide with it, but I decided to remove it just before coming on stage because it feels like out of topic. So there are important differences between ProxySQL and MySQL router. Both of them are router in front of MySQL. Now, MySQL router provides way less functionality compared to ProxySQL. This is one of the main difference. And like query cache is not there. Query write, I think, is not there. All the observability, there is nothing like this in MySQL router. Now, this is just for built-in features. And another important thing is that MySQL router normally works with just one InnoDB cluster. ProxySQL does not have this limitation. As I was mentioning before, we have customers in which behind every single ProxySQL, they have thousands of clusters. You cannot do this with MySQL router because MySQL router is tightly integrated with one InnoDB cluster. And of course, this creates a lot of other limitations because they work as a pair. While in case of ProxySQL, we can have we can have different type of clusters. Like behind one ProxySQL instance, you can have Aurora, and at the same time, you can have Galera and group replication and so on. And or send traffic to a replica that is replicating from InnoDB cluster and so on. So this is one important difference. And you have other difference. Like in MySQL router, I think the current client limitation is 15,000, if I'm not mistaken, or 50,000, I can't remember. ProxySQL does not have any hard code limitation. So like we have clients, they have 500,000 connection to ProxySQL. So ProxySQL scales a lot better compared to MySQL router. Now, one of the things that MySQL router is better because of his integration with InnoDB cluster is that the bootstrap of MySQL routers works seamless with InnoDB cluster. ProxySQL is a bit more complicated. It might need a bit more configuration, but because ProxySQL is more generic. We have a bootstrap mode we introduced in 2.6, if I remember correctly. So ProxySQL is able to detect the configuration that you can have in InnoDB cluster for MySQL router. So ProxySQL will pretend it is a MySQL router. We'll read the configuration of MySQL router. But of course, there is no one-to-one mapping in that case.
Rene, I think it's more an idea. I don't know you do it. Do you pretend in the future instead using regex for detecting queries in firewall, will use fingerprints of queries?
We are working on adding a parser in ProxySQL. So we are currently developing it. It's not a hidden features like everything is going on a PR currently as we speak. So the idea will be that in the near futures, this parser will handle just set statement, but this will be the first step. The second step is we'll be able to detect and parse any sort of queries. And then when this happens, of course, it will open way more capability in ProxySQL, like being able to perform query rewrite, not just based on regex, but any other criteria. Thanks.
Rene, a quick one. I know that you didn't say anything there, but can you explain a little more about mirroring? We use a ton on migrations.
Yes.
And yeah.
So one of the features that ProxySQL has, and is not present in this slide deck, is mirroring. That is basically the ability of ProxySQL detecting. You configure ProxySQL that every time it is seeing a specific query pattern, it can execute the same query also on a different host group. And this can be useful for multiple reasons. It can be useful for detecting performance difference in a MySQL server. So you can have traffic, normal traffic goes to MySQL version X, and you said, okay, not just send traffic to that version, but also send traffic to a different MySQL version and collect statistics about it. And ProxySQL, because ProxySQL is able to detect metrics, you are able to compare the performance of those two. The mirroring has also another important features, that is the ability of rewriting the queries that are sending to mirror. So you can also implement something like send the regular traffic to a specific server or a specific host group to be more precise. And then the mirror is being rewritten. So you don't just send the query to a different server, but you also rewrite it. And you can compare if it produced the same result and what are the differences after rewriting a query. So it allows you to not just check performance, but also to test rewrites, if this is the case. One important thing about mirroring that a lot of, is a concept that a lot of people misinterpreted. Mirroring cannot be used as a replacement for replication. So if you are sending write to a server, don't use mirroring to send the same writes to a different server, because this is not the way of duplicating data, because you can have, there is no guarantee that queries are executed in the same order. There is no guarantee that if a DML succeeds on one server, it will also succeed on another one. So do not use mirroring for replication.
Here,
Hi.
what about the high availability of SQL proxy? You explained that we can connect to a high available MySQL, but what about this single point of failure that it creates?
Yes. Okay. We can have a whole session on this topic because it really is a complex topic. So you can have high availability in multiple ways. One of the common one is to use a multi-layer ProxySQL. But again, this really depends from your specific architecture. So the two most common solutions are to run one ProxySQL instance in every application server, And this scale until a certain point, because if you have few application server, it is absolutely a reasonable solution because you have the application and ProxySQL as a bundle. But if you have thousands of application server, this solution does not work anymore. So what you will end up is another common solution is either having multi-layer ProxySQL. So in the application, you use a very simple ProxySQL instance that does nothing more than relying traffic to another middle layer of proxy. So the application will connect on localhost 127.0.0.1, and this ProxySQL is configured as extremely lightweight, and it's only forward traffic to a set of proxies. And of course, this set of proxies that are the middle layer, they will be considered by the first layer of ProxySQL as database server. So it will implement all the logic of failover. So you can send traffic to 5 ProxySQL instances. If one of those 5 goes down, the upper layer will detect that one of them went down, so we'll stop sending traffic to it. And the application will not even see any error most of the time. And of course, you can have way more complex scenario, like you can use virtual IP, you can use, we have customers in which they actually couple ProxySQL with the database server. You know, there is actually a big customer that is using this approach. So they only care about the failover of the database server. They don't really care about the failover of ProxySQL because they consider them as a pair. So it really depends from your architecture. And this is why I said, like, we can have a whole session about it, like 30 minutes topic. Yeah. Any other question?
Okay, I think we can discuss
I'm moving
later.
to the next slide, not to stop the question, but because there are links and the QR code. So maybe it's better if this slide stays on screen instead of the previous one. But yeah, if there is more question, I'm here, happy to answer.
Hi, guys. Thanks, Rene.
Thank you. Thanks. Final note, please join the community. So there is the website, the GitHub repo, and this is my LinkedIn QR code. Thanks.
Obrigado, Rene. Thank you.
Obrigado.
Bom, pessoal.